All right, Algebra 1 students, this is our video on the greatest common factor. Shouldn't be a long video, but it should be a quite useful one. And let's get started with some definitions. Factors are the values that are multiplied to get a product. So when we think about factors, if I said factors of 24, you'd be talking about the numbers 1, 2, 3, 4, not 5, 6, not 7, 8, not 9, 10, 11, 12, and that's it. Oh, wait, nope, that's not it. 24, because all numbers are factors of themselves. So every number is a factor of itself. When we talk about multiples, multiples are what you get after multiplying a number by an integer. So the multiples of 24 be 24, 48, 72, 96. I'm going to use a ... at that point because you get my drift here. Let's talk about something real quick. Factors, that list, the list of factors is finite. Factors, finite. It's a finite list because there are only so many factors. Okay? With multiples, there are many, because you could find multiples forever, hence the ellipsis at the end of my list of multiples of 24. The greatest common factor of a set of monomials is the largest monomial factor that is a factor of each term in the set. So before we talk about that, let's talk about divisibility rules. Now, I'm not going to go through this in great detail. You are welcome to write them down, but if you just read them and listen, you probably already know them all. There might be some cool tricks in here. I don't know. So let's go through these briefly. So first of all, if a number ends in 0, 2, 4, 6, or 8, it's divisible by 2. In other words, if it's even. For threes, if the sum of the digits is divisible by 3, then you have a multiple of 3. 79 is not, because 7 plus 9 is 16. And 3 doesn't go into 16. So there's an example of one that's not. You could try 36, for example. 3 plus 6 is 9, and 3 does go into 9. Okay, number 4, the number 4. A number is divisible by 4 if the last 2 digits are divisible by 4. So that's a cool way that you can check if you have a longer number. The last 2 digits are divisible by 4, then the whole number is. You can also do cut it in half again. If you have it and then halve it again, halve, H-A-L-V-E, if you cut something in half, cut it in half again, you are still going to get a whole number if it's divisible by 4. Ends in 5 or 0 is your rule for 5. To find out if a number is divisible by 6, it's got to be divisible by 2 and 3. There is sadly no simple test for divisibility by 7, but remind me in class, I have a cool trick for that, for divisibility by 7. Okay, 8. If the last 3 digits are divisible by 8. Now, that's not as useful, okay? It's useful when you have a larger number and no calculator, but that's just not as useful, those 3 digits. If you want to also think about another rule is you could divide by 2 3 times. If you divide by 2, divide by 2, divide by 2 again, and you still have a whole number, the original number was divisible by 8, because 8 is 2 times 2 times 2. For 9s, add your digits again. If you add the digits and then add the digits and then add the digits all the way down, so even if I go down 2 plus 7 here, we are going to get a multiple of 9. We are going to get the number 9, actually, when you go all the way down to it. So if you keep adding the digits of the answer you get after you've added the digits of the original number, eventually you'll get a 9. That original was divisible by 9. And obviously for 10, it ends in 0. So let's look at the rules of finding the greatest common factor. First of all, find the greatest common factor of the coefficients. And we're going to do that with a pair of numbers down here at the bottom in just a minute. If both the numbers you have are negative, then the GCF is automatically negative. Find the smallest exponent that is common to each term for each variable. These are the common variable factors. If you find the product of those common factors, both the numerical part from this and the variable part from that, you get the greatest common factor. Let's try the first one, 24 and 60. Now, I told you that, or I don't believe I told you, I'm going to tell you now, I don't use the same method that the textbook might use. So I don't prime factorize. I don't list out the factors. I start with the smaller of the two numbers, and I start by asking, does 24 go evenly into 60? No, it doesn't. So now I need to start finding factors of 24, and you start from the top down. So the next largest factor of 24 is 12. Does 12 go into 60? Yes, it does. So does 12 go into 60? Yes. So our GCF for this one is 12. All right, next one. Again, I'm looking at the numbers first, 36 and 54. Does 36 go into 54? No, it does not. Okay, so let's work our way down. Does 18 go into 54? Yes, it does. It goes in 3 times. So the number 18 is going to be in my greatest common factor. Now look at your variables. You have x to the 4th, and you have x squared. I can take an x squared and divide that out of both of these, and since 2 is the smallest exponent that they both have in common, okay, when we say have in common, this one has more than x squared. So x squared is contained inside x to the 4th. Think of x to the 4th as x squared times x squared, in fact, or x squared, the quantity squared even. So you can take out up to x squared from each term, and that's as much as you can take out. So GCF there, 18x squared. Sometimes it's going to be obvious. If you see the numbers 121 and negative 55, hopefully you automatically realized that the GCF of both of those numbers is going to be 11. Now you want to look at your variables. We have a to the 1st, and then we have b squared. So that's the GCF for this pair of monomials. 11, because 11 is the biggest number that goes into both 121 and negative 55 evenly. A, because it goes into a, right here, and it also goes into a cubed. And then b squared, because that goes into b to the 4th, and it also goes into b squared. Okay. What is factoring? Well, factoring is the process of finding factors. So it's breaking an expression down. Factoring is the process of finding factors. It's the process of breaking an expression down into its individual factors. When we factor a polynomial that has a greatest common factor, a GCF, we are dividing that GCF from every term. The factored form is written as the product of a monomial and a polynomial in parentheses. I like to call this Jeopardy math, because when you are learning how to do factoring, it's as if you're giving me the original problem that was used to find the polynomial in front of you. So let's try a few. Find the GCF of each polynomial, then factor the polynomial. So the 2 terms in the first one are 5z and 35. So let's start here, number 1. 5z minus 35. Well, the GCF of those 2, there is no variable in common, so there'll be no variable in my greatest common factor. Remember, common means same for both, and there's no variable on the 35. 5 does go into 35, so I found my GCF. To factor it out, you put it out front, and inside the parentheses, you put what you would get if you divided each term by 5. Well, 5z divided by 5 is just z, and 35 divided by 5 is 7. And that is the answer for that first problem. That's the factored form of the polynomial. Number 2. 8y cubed plus 4y. Start with the numbers. 4 does go into 8. Therefore, 4 has to be part of my greatest common factor. If I look at my variable terms, I have y cubed and I have y. So there is y to the 1st power in my greatest common factor. Put it out front. And what do you get when you divide? Well, 8y cubed divided by 4y. 8 divided by 4 would be 2. Y cubed, divide off y, would leave me y squared. 4y divided by 4y would leave me a positive 1. And that is my answer for the second problem. Okay, for number 3. 9x squared minus 15x to the 4th plus 12x squared. So now I have 3 numbers to be thinking about here. Start with the smallest of the numbers, 9. 9 goes into neither 15 nor 12. What's the largest number that's a factor of 9 that's less than 9? Well, that's 3, and 3 goes into all 3 of them. So there is a 3 in my GCF. Now look at your variable terms. Since it's in standard form, oh, I copied something wrong. Hopefully you guys caught that. Unfortunately, I'm going to have to write over top of it because I can't erase. When I switch back and forth between tools, it won't let you erase. So anyway, now that you've stopped and written me an email about my mistake, and now that I've caught it, you can, just go back and tell me to disregard the email. I know some of you get really excited when you find my mistakes, and there's nothing wrong with that. I am very human, terminally human even. So anyway, back to what we were doing. X to the 6th, x to the 4th, x squared. The largest exponent they all have in common is 2, so x squared is in my GCF. Put it out front. Inside is what you would get if you divide every term by 3x squared. 9 divided by 3, 3. x to the 6th divided by x squared, x to the 4th. Minus 15 divided by 3, 5. X to the 4th over x squared, x squared. 12, or plus, 12 divided by 3, 4. X squared divide off an x squared, no x squared in the answer. So at that point, I can move my parentheses over, and that is the correct answer for number 3. And for the last one, number 4, which is 6a cubed b to the 5th minus 18a squared b to the 3rd. All right, 6 and 18, 6 does go into 18, so 6 is part of my greatest common factor. A cubed and a squared, 2 is smaller than 3, so a squared is in my common factor. B cubed over here, b to the 5th over here, b cubed is in my common factor. Well, what do we get when we divide that off? Well, 6 divided by 6 is 1. Well, I'm not going to write the 1. A cubed, divide off an a squared would leave you with a. So right now we have a in the first term inside the parentheses. B to the 5th divided by b cubed would be b squared. Now let's get a visual for this, just in case you were confused. This is what I'm actually doing when I say divide it off. So that's supposed to be a 2. It's just really messy. So that means, not 15, silly, 5. So that means 6 over 6 cancels. A squared cancels out 2 of these, leaving 1. And b cubed cancels out 3 of these, leaving 2. And then 18 divided by 6 is 3, so minus 3. It's not 8, it's 3, I'm sorry. A squared, divide off an a squared, is going to be no a left. And b cubed divide off b cubed is going to be no b left. So I can move the parentheses in for this one too. And that is factoring a polynomial, factoring out the greatest common factor from a polynomial. Hope it makes good sense. We're moving on with our favorite F word, second favorite F word in algebra, which is factoring. Continuing on next class. I'll see you guys when you come to class.